Ever wondered what would happen if the Earth just stopped spinning? Like, completely stopped.
Oh.
It sounds crazy, right?
Yeah.
But the effects would be pretty wild. Today, we're going to deep dive into this crazy scenario.
Okay.
And we're using Vsauce as our source. You know Vsauce, right?
Oh, yeah.
That YouTube channel.
Yeah.
That makes science fun.
Uh-huh.
So we're going to look at what would happen
Okay.
if the Earth suddenly braked. What would be the consequences?
Well, one of the things that's really interesting about this question
Yeah.
is that it kind of shows how deeply our existence is tied to the rotation of the Earth.
Right.
It's not just about day and night.
Yeah.
It affects everything.
Oh, yeah.
From like how much we weigh to even the shape of the Earth.
Okay, let's unpack this.
Yeah.
Vsauce painted this pretty dramatic picture. If the Earth suddenly stopped spinning,
Okay.
everything on the surface, except at the poles,
Right.
would be flung to the east
Yeah.
at over 1,000 miles per hour. They compared it to being like a supersonic tumbleweed.
Oh.
Basically like a 9.5-inch caliber bullet.
Wow. That
Why would that happen?
is wild.
Yeah.
Well, it all comes down to inertia.
Inertia.
Yeah. So right now,
Uh-huh.
we're moving along with the Earth's rotation at a constant speed.
Right.
But if the planet just suddenly stopped,
Yeah.
our bodies would still want to keep going at that same speed.
Okay.
Think of it like
Yeah.
slamming on the brakes in a car.
Uh-huh.
You get thrown forward.
Right, right.
It's the same principle, but on a planetary scale.
So it's not that we wouldn't feel the Earth stopping.
Yeah.
It's that we'd feel the effects of
Yep.
it stopping,
Yeah.
like really abruptly.
Exactly.
Right.
And the effects wouldn't just be limited to us getting flung eastward.
Okay.
That sudden stop would trigger, like, a ton of crazy events.
Like what?
Oh, there'd be supersonic winds,
Oh, wow.
massive fires.
Fires. Why fires?
Sparked by friction.
Friction from.
Yeah. Unprecedented erosion carving up the whole landscape.
Jeez.
And tsunamis.
Tsunamis. Oh, man.
Kilometers high.
Oh, my gosh.
That would completely reshape the continents as we know them.
So it's starting to sound less like a thought experiment and more like a disaster movie.
Yeah, definitely.
But why would the oceans migrate to the poles? Wouldn't they just slosh around a bit?
It wouldn't be that simple.
Okay.
Because without that Earth's spin,
Yeah.
the centrifugal force
Mm-hmm.
that pushes the water toward the equator
Okay.
would disappear.
Right.
And then the stronger gravitational pull of the poles would take over.
Oh, okay.
And it would draw all that water towards them.
Gee.
And then ultimately the Earth would be reshaped into a more perfect sphere.
So we'd go from this chaotic, flung around, burning, flooded mess to a smooth, round, watery world.
Basically.
Doesn't sound like much of a trade-up, really.
No,
What about the sun? Vsauce mentioned that days would become like a year long.
that's right.
How does that work?
With no rotation,
Yeah.
the sun would appear to just stay fixed in the sky,
Right.
taking a whole year for the Earth to orbit around it.
Okay.
Just imagine, 6-month-long day,
Oh my gosh.
followed by a 6-month-long night.
That's some serious jet lag.
Yeah, I can't even imagine.
And what about Earth's magnetic field? You mentioned earlier that it's generated by the planet's rotation.
Right. Well, that magnetic field
Uh-huh.
acts as a shield
Right.
against harmful solar radiation.
Okay.
Without it,
Yeah.
we would be exposed to lethal doses,
Oh, wow.
making survival on the surface pretty much impossible.
Okay, so it's not just about like the initial chaos of being flung around.
Yeah.
It's the long-term consequences
Exactly.
that would really make this like a recipe for disaster,
It would be a complete disaster.
Yeah.
And it shows how interconnected everything is on our planet
right?
and how crucial the Earth's rotation is for life as we know it.
Okay, but here's something I'm curious about. Vsauce also mentioned that the Earth's spin affects our weight.
Yes.
Is that true?
Yes. So like right now
Mm-hmm.
at the equator,
Yeah.
you actually weigh slightly less
Less.
than you would if the Earth wasn't spinning.
Really?
Yeah, it's due to the centrifugal force
Okay.
created by the Earth's rotation,
Mm-hmm.
which kind of acts in opposition to gravity.
So the Earth spinning is kind of like a built-in weight loss program,
In a way, yeah.
albeit a very tiny one.
Yeah, very tiny.
But if the Earth stopped spinning, we'd lose that tiny bit of weight reduction.
Yeah, but honestly,
Yeah.
at that point, worrying about a few extra pounds
Yeah.
would be the least of our concerns.
Good point.
Yeah,
It's amazing how much we take for granted about the Earth spinning.
it really is.
Speaking of seemingly simple things,
Hmm.
let's talk about time.
Okay.
Because Vsauce pointed out that even though we think of time as constant,
Yeah.
it's actually tied to the Earth's rotation,
Right.
which isn't as steady as we think.
Absolutely. And events like earthquakes,
Uh-huh.
melting glaciers,
Okay.
even large-scale human activities can affect the Earth's rotation speed.
Wow. Really?
Yeah.
So, like, stuff that we're doing
I
can
know.
actually affect how fast the Earth is spinning.
It can.
That's wild.
It's pretty crazy.
Okay, so we've established
Yeah.
that the Earth's rotation isn't perfectly consistent,
Right.
and that even subtle changes
Mhm.
can affect our timekeeping.
Exactly. And that's where things get really interesting.
Okay.
Yeah.
It highlights how science has to adapt, right,
Yeah.
to the realities of a dynamic universe.
It really does.
Like, we can't just assume that time
Right.
is this perfect, smooth, linear thing,
Exactly.
especially when we're dealing with a planet that's
Yeah.
constantly, like, changing its spin.
Yeah, constantly adjusting.
Okay, so how do scientists measure these, like these
Huh.
tiny variations
Yeah.
in Earth's spin?
Well, that's where these things called atomic clocks come in.
Atomic clocks.
Yeah, they measure time based on the super consistent vibrations of atoms,
Uh-huh.
and then they compare that atomic time
Yeah.
to observations of distant stars.
Okay.
And that's how scientists can figure out exactly
Right.
how much the Earth's rotation is changing.
So they're like this cosmic stopwatch,
Good
basically,
Kind of
giving
ex-
us this super accurate view
Yep.
of how the Earth's rotation is changing.
Uh-huh. And it's because of these tiny variations
Right.
that we have to make adjustments
Yeah.
to our timekeeping system.
And that's where leap seconds come in.
Exactly.
This whole leap second thing is so interesting.
It is fascinating.
It's like we're manipulating time itself
In a way, we are.
to, like, fit our needs.
Right.
But it's not about, like, cheating time.
Yep.
It's about reconciling our
Right.
human construct of time
Uh-huh.
with, like, the physical reality of our planet.
Exactly.
Like, we've divided time into
Yeah.
days, hours, minutes, seconds,
Right.
all based on the Earth's rotation.
Yeah.
Uh-huh.
But if that rotation isn't perfectly consistent,
Yeah.
then, like, our timekeeping needs to be flexible enough to adjust.
Exactly.
So leap seconds are a reminder
Yeah.
that, like, our understanding of time is always evolving.
Yes.
And it makes you wonder, like, what other fundamental concepts
Right.
might we have to, like, rethink
Yeah, that's a great question.
as we learn more about the universe?
It really does remind us that even the things we take for granted
Yeah.
as, like, constant, unchanging
Mhm.
are often much more complex than we realize.
Speaking of things we take for granted,
Yeah.
let's go back to that idea of weight
Okay.
and how it's affected by the Earth's rotation.
Uh-huh.
Because Vsauce mentioned something about being weightless.
Right.
If the Earth spun 17 times faster,
Yeah, that's right.
which sounds like a wild ride.
Oh, yeah.
How's that even possible?
Well, it comes back to that balance
Right.
between gravity and centrifugal force.
Uh-huh.
So as the Earth spins faster...
That centrifugal force pushing outwards gets stronger.
Okay.
And if the Earth were to spin 17 times faster,
Uh-huh.
that centrifugal force would be so strong
Right.
that it would actually perfectly counterbalance gravity.
Whoa, so we'd be weightless.
You got it.
I'm trying to imagine, like,
Yeah.
what it would be like
Yeah.
to suddenly be weightless, just
Yeah.
floating around as
Yeah.
the Earth spins that fast.
Yeah.
Could we still function normally?
Well, that's a question
Sure.
for maybe the biologists
Right.
or
Yeah.
maybe the stunt coordinators.
Right.
But from a physics standpoint,
Yeah.
it's fascinating to think about, like,
Yeah.
how much our experience of the world would change
Right.
if we just altered this one fundamental thing.
It's true.
Yeah.
And Vsauce also talked about how the Earth's magnetic field
Uh,
is generated by its rotation.
right.
And we talked about,
Yeah.
how losing that magnetic field would be
Yeah.
a catastrophe,
It would be a disaster.
exposing us to all this harmful radiation from the sun.
It's essential for life as we know it.
Yeah.
It's like a shield protecting us
Right.
from all those high energy particles
Yeah.
that can, damage our DNA
Uh-huh.
and lead to a bunch of health problems.
It really makes you appreciate
Yeah.
how this seemingly simple thing,
Right.
like the Earth spinning,
Yeah.
has such profound effects
Right.
on our lives,
Uh-huh.
on the planet as a whole.
It's a perfect example of how
Yeah.
interconnected everything is in the universe.
Okay, so far we've covered a lot,
Yeah.
like supersonic tumbleweed apocalypse,
Yep.
migrating oceans,
Yeah.
the manipulation of time itself,
Uh-huh.
weightlessness,
Right.
the importance of Earth's magnetic field.
Yeah.
But Vsauce took this thought experiment even further
Okay.
by bringing in the concept of space-time.
Oh, wow.
So space-time is
Yeah.
basically...
It's like a four-dimensional framework. That combines the three dimensions of space.
Right, like length, width, and height,
Exactly.
with the dimension of time.
You got it.
So instead of thinking of space and time as like
Right.
separate things,
Yeah.
we're merging them into this
We're combining them.
single unified fabric.
Precisely. And
Yeah.
just like if you put a bowling ball on a trampoline,
Yeah.
it creates a dip, right?
Right.
Massive objects like planets and stars
Uh-huh.
actually warp space-time.
Really?
Yeah. And as the Earth spins,
Yeah.
it drags space-time along with it,
Oh. Warren.
creating kind of a swirling effect.
I'm trying to picture this,
Yeah.
the Earth dragging space-time along with it as it spins.
That's exactly what's happening.
What happens to that swirling effect
Hmm.
if the Earth suddenly stops? So we've got this swirling effect around a spinning Earth. What happens if the Earth suddenly stops?
Well, that's where things get really, really interesting.
Okay.
And we sort of step into the realm of speculation.
Speculation.
Okay,
Yeah.
so some theories suggest
Yeah.
that a sudden stop could create, like,
Yeah.
ripples in space-time.
Ripples. So like
Yeah.
aftershocks of an earthquake, but like
Exactly, but on a cosmic scale.
cosmic scale. Oh my gosh.
Yeah,
Would we be able to feel those ripples?
that's debatable,
Okay.
but the theoretical implications
Yeah.
are pretty mind-blowing.
Like what?
Well, some physicists speculate that those ripples
Mm-hmm.
could even create temporary wormholes.
Hold on. Wormholes. Like the things from sci-fi movies
Exactly.
that let you travel through time
Uh-huh.
or to other dimensions?
Yeah, potentially.
Are we saying that like if the Earth stops spinning, it could
Yeah.
rip open the fabric of reality?
Again, we're deep into theoretical territory here.
Okay.
We've never actually observed a wormhole,
Right.
and the conditions to create one are
Yeah.
pretty extreme.
Okay.
But the idea that a sudden stop
Uh-huh.
could have such profound effects
Yeah.
on space-time, it's pretty captivating.
But it's incredible to think that something as like
Right.
mundane as the Earth spinning
Yeah.
could potentially open pathways
It's wild.
to other dimensions
Yeah.
or like parallel universes.
Eventually.
My mind is blown.
It is pretty remarkable.
It's like we've gone from a disaster movie
Yeah.
to like an epic sci-fi adventure.
It is pretty crazy thought experiment.
This whole deep dive has been a wild ride.
Yeah.
We started with like
Right.
the real tangible effects of a sudden stop.
Right, like the flinging.
Yeah, the flinga,
Yeah.
the tsunami,
The tsunamis, the magnetic field.
a loss of the magnetic
Yeah.
field. And we ended up exploring like
Yeah.
the very nature of time, gravity,
Yeah.
and the fabric of reality.
It really shows how interconnected everything is.
Yeah.
And how much we still don't know about the universe.
We really do take for granted, like
Yeah.
the things that seem constant and unchanging.
Absolutely, like Earth's rotation.
But when we start to explore these what ifs, it reveals how much more there is to discover.
It's so true.
Well, we might not be traveling through wormholes anytime soon.
Probably not.
But this deep dive has certainly stretched my imagination.
Mine too.
It really makes you realize
Yeah.
that the universe is so much stranger and more wondrous
It is.
than we give it credit for.
Absolutely.
So as we wrap up this
Yeah.
thought experiment, I want to thank you
Oh, well, thank you for having me.
for taking us on this incredible journey
Oh, it's been my pleasure.
into the what ifs and maybes of a world
Yeah.
where the Earth suddenly stops spinning.
Well, that's definitely a fascinating thought.
So to everyone listening,
Yeah.
until next time,
Uh-huh.
keep looking up
Yeah.
and keep wondering.
Absolutely.